Okay, we're doing section 7.3 on discriminants. And the instructions for the first couple that I assigned, number 1 and 3, said determine the nature of the roots. And so if you remember, what they're asking us to do is to look at the discriminant. Now the discriminant is that little piece of the quadratic formula, the b squared minus 4ac. It's under the radical in the quadratic formula. And if that number equals to 0, we only have one real root. It's actually a double root. We could say there's two roots, but they're the same root. They're the same number. So you only get one different answer, okay? If it ends up being a positive number, if it's bigger than 0, in other words, if b squared minus 4ac is bigger than 0, if it's positive, you get two real roots. And if b squared minus 4ac is less than 0, if it's negative, you get two imaginary roots. And they're actually conjugates of each other when that happens. So we're going to look at some of these problems and see what happens here. Let's just pick one out of 1 and 3. Let me go with number 3, okay? Just for example, t squared plus 8t plus 20 is equal to 0. Now, they're not actually asking us to find the solutions. They're just asking us to tell how many solutions there are. So if I do the b squared minus 4ac, let me see, my a is 1 here. It's the coefficient of the t squared term. My b is this positive 8, and my c is positive 20. So if I do b squared minus 4ac, I can see really quickly what kind of roots I'm going to have. All right, so b is 8, so I have 8 squared minus 4 times a times c. So this is 64 minus 80. Well, that's going to be a negative number. It really doesn't matter what it is, but it's going to be a negative number. It's actually going to be negative 16, I believe. So since it's negative, under that radical, you're going to get negative 16. That means you're going to have two roots, but they're going to be imaginary. And because they're imaginary, what happens is you're going to get something plus 4i, something minus 4i on the top. That means you're going to actually end up with two roots that are conjugates of each other. Remember, a conjugate is just like if I had 3 plus 4i, the conjugate would be 3 minus 4i. And we keep seeing that that's what's happening when we find these roots. Now, in the other sections that I had you look at, you're just looking to see what's the easiest way to solve these things. So how can we solve? Well, we can factor. Seems to always be the fastest thing to do. We can do the quadratic formula. We can take square roots if it's an easy one to do square roots on, and if it's not an easy one to do square roots, we can complete the square and then do the square root. Most people prefer not to complete the square, so they tend to stick with either factoring or quadratic formula unless they see something that's just really easy to solve. For example, let's see. One that would be easy to solve with square roots would be like 17. 5 times x plus 7 squared is equal to 0. Well, if I divide both sides by 5, I get x plus 7 squared is equal to 0 still. And if I square root both sides, I just get x plus 7 equals 0. And if I subtract 7 from both sides, I get x equal negative 7. That was really fast to solve by doing square roots. You could have done another method, but that would have been the fastest way to do that one. So we've got all these tools, and right now what we're trying to do is just what would be the easiest way to solve them. Pick some, like for instance, number 21 would also be easy to solve with square roots. If you're looking at 23, oh man, you don't want to go do that the hard way. This is just so easy. All you got to do, it's already set equal to 0. You just got to say, oh, it's already factored. 2x plus 5 equals 0. X minus 3 equals 0. And you could just, really quickly do the math on that. Subtract 5, get 2x is negative 5. Divide by 2. X is negative 5 halves. And this one up here is real easy. We just add 3 to both sides, and we get x is 3. So our solutions are negative 5 halves and 3. So that was really easy because they actually already had it set up really nicely for us. We'll kind of backtrack a little bit. So let's look at number 13. What would be the easiest way to do that one? Well, that one looks to me like it's going to, you wouldn't want to do it the hard way if you could factor it. And remember on this one you're thinking, okay, it's just a plain old x squared kind of problem. What multiplies to give me 5 and adds to give me negative 6? Well, how about negative 1 and negative 5? You could factor that. X minus 1, x minus 5 equals 0. Set each one equal to 0 and solve. You know, that's really fast to do, isn't it? You get x is 1. That's a lot better than doing the quadratic formula, because the quadratic formula takes so long. So we can get our answers really quick here of 1 and 5. Now 15, I don't know how you want to do that one. If you want to try to factor it, maybe you could use the quadratic formula on it if you don't want to try to factor that, and a lot of people would say, hey, that's what I want to do. Oh wait, this is plus 4. That's not a 14, that's a plus 4. Now I'm looking at this thinking, this factors pretty easily, because this is a perfect square. It's 3x squared. And this is a perfect square. It's either 2 squared or negative 2 squared. It's actually going to be negative 2 squared, and the reason I know that is because there's a negative right here. And if you remember, if this is a perfect square, if I multiply 3x and negative 2, I get negative 6x, and it's a perfect square if I can double it and get the middle term. And that's what happens here. This one's easy to factor if you recognize the pattern that it's a perfect square. It's 3x minus 2 times 3x minus 2, check it out if you don't believe me, which is just 3x minus 2 squared. Now you could do that, it's equal to 0, right? So to solve it, all you got to do is say 3x minus 2 equals 0, and add 2 to both sides, and get 3x equal 2, and then divide by 3, and you get your answer. X is 2/3. It goes that fast if you factor it. Now, if you do the quadratic formula, it's going to take you longer. So I'm hoping that what you can see here is that, yes, you got all kinds of tools, and you can use them whenever you want to. If you didn't see this factoring pattern, and you could have tried to factor it with splitting the middle term. But if you know that's your weakness and you want to use the quadratic formula, you should still get the same answer here. So this section is just basically trying to kind of have you put all your stuff together and say, hey, we can tell how many answers we're going to get, and you know, by using the discriminant. That's what the top part was about. And then the bottom part was just, let's just solve some different equations, and let's be smart about what tool we pick.